Hello everyone. In this lesson, we are going to talk about hyperbola. So here, we will define a hyperbola, know the forms of its standard equation, and solve some problems involving hyperbolas. So let us now consider the definition of hyperbola. We have here let f sub 1 and f sub 2 be two distinct points. The set of all points whose distances from f sub 1 and from f sub 2 differ to a certain constant is called a hyperbola. The points f sub 1 and f sub 2 are called the foci of the hyperbola. Now, to better understand this definition, let's consider this illustration. So this is how a hyperbola looks like. Now, suppose we have f sub 1 be negative 5, 0, and f sub 2 be 5, 0. Now, from the definition, the set of all points whose distances from f sub 1 and from f sub 2 differ to a certain constant is called a hyperbola. Now, let's consider one point on the hyperbola. Okay, suppose that is point A with coordinates 3.75 and negative 3. Now, we are going to take the distance of this point from f sub 1 and from f sub 2 and take the difference. Now, from here, a to f sub 1 is longer than a to f sub 2. So, we will have a to f sub 1 minus a to f sub 2, and that is equal to a to f sub 1 by distance formula, we have 9.25. And a to f sub 2 is 3.25. Now, taking the difference, that is equal to 6. Now, if I'm going to take another point on the hyperbola, suppose that is point P with coordinates negative 5 and 16 over 3, the difference of the distances should be the same with the difference na nakuha natin kanina, which is 6. Okay, so let's try. B to f sub 1. Okay? And B to F sub 2, as you can see, B to F sub 2 is longer than B to F sub 1. So we will have B to F sub 2 minus B to F sub 1, and that is equal to, by distance formula, B to F sub 2 is 34 over 3, and B to F sub 1 is 16 over 3. Now, solving, we will have 6. So as you can see, the difference of the distances are the same. So we have 6, both points A and B. There are also other points P on the hyperbola such that the difference of the distances of that point from f sub 1 and from f sub 2 is equal to 6. Now take note that the point could be located on the right side of the hyperbola, meaning the right curve of the hyperbola, or on the left curve. If the point is located on the right curve, the formula will be P to F sub 1 minus P to F sub 2. And that should be equal to 6 in this case, right? And if the point is located on the left curve of the hyperbola, the formula will be P to F sub 2 minus P to F sub 1. That is also should be equal to 6 in this case, right? So since the points could be located on the right side or on the left side, to guarantee that the same difference of the distances, we will now take the absolute value of P to F sub 1 minus P to F sub 2, and that should be equal to 6. Okay, so this is now the property that we are going to use. The absolute value of the difference of any point on the hyperbola, okay, from f sub 1 and from f sub 2 is constant. So in this case, we have 6. So the constant here could be any number. Okay, so let us now identify the parts of this hyperbola. Okay, so we have here the parts of the hyperbola. The first one are these points f sub 1 and and f sub 2. So those are from the definition. Those are the foci of the hyperbola. So we have here focus 1 and focus 2. Okay? We also have this point C on the middle of these 2 points. Okay? This is the center of the hyperbola. Okay? We also have these 2 points, V sub 1 and V sub 2 on the curve of the hyperbola. Okay? So V sub 1 and V sub 2 are called the vertices of the hyperbola. Okay? You can also see here these two intersecting lines. Okay? These two intersecting lines are what we call the asymptotes of the hyperbola. So, in graphing the hyperbola, we need the asymptote because we will just let the curve of the hyperbola approach the asymptote, but it will never touch the asymptote. Okay? You can also see here this imaginary box, a rectangular, a rectangle. Okay, this is what we call the auxiliary rectangle. This is very important in graphing hyperbolas because the auxiliary rectangle will determine the asymptotes of this hyperbola. Okay, so we will just connect the corners of the auxiliary rectangles, or the diagonals. We will take the diagonals and extend it. Then we will now have the asymptotes. Okay? Now, if we are going to connect V sub 1 and V sub 2, we can actually get an imaginary segment, line segment here, V sub 1 and V sub 2. This is what we call the transverse axis. Okay? So, there. And this segment perpendicular to the transverse axis with its endpoints on the auxiliary rectangle is what we call the conjugate axis. So this axis will determine the auxiliary rectangle. Okay, when graphing the hyperbola. Okay, so these are the parts of hyperbola. Okay, and by the way, as you can see here, the points are aligned horizontally. That's why the hyperbola opens to the left and to the right. Okay, so in this case, the hyperbola is horizontal. Okay, these two curves here, okay, are what we call the branches of the hyperbola. So we have the left branch and the right branch. Let us now have the forms of the standard equation of a hyperbola. Okay, so the same with parabola and ellipse. The standard equation of a hyperbola depends on its orientation. So here, we will be considering two orientations. So the first one, pinakita ko na yan kanina. The horizontal hyperbola. So you can see here that the branches of the hyperbola are opening sideways, meaning it opens to the left and to the right, or the points are horizontally aligned. Now, what is the form of the standard equation when the hyperbola is horizontal and the center is at hk? So this will be the form. We have x minus h quantity squared over a squared minus y minus k quantity squared over b squared equal to 1. Now, when the center is at 0, 0, meaning at the origin, your h and k becomes 0 here. So the standard equation will be x squared over a squared minus y squared over b squared equal to 1 na lang siya. Okay? Now, if your hyperbola is vertical naman, meaning the branches are opening upward and downward, or the points are vertically aligned, the form of the standard equation will be this one. For the center, HK. And for the center at 0, 0, we have this. Okay? So as you can see, di ba sa ellipse, yung titignan natin ay yung denominator kasi sila yung nag-change. Dito naman sa hyperbola, yung nag-change ay yung numerator. So titignan natin yung numerator. When the positive part, meaning yung nasa unahan, ay si x minus h. So, the orientation is horizontal. Yung negative part natin dito ay si y minus k. If positive si y minus k and negative si x minus h, vertical naman yung hyperbola natin. Okay? Also, di ba sa ellipse, yung A is always greater than B. Okay? Sa ellipse, A is always greater than B. Dito sa hyperbola, iba naman siya. Okay? Si A could be greater than B. Okay? Si A could be greater than B. A could be less than B, or A could be equal to B. Kasi mamaya makikita nyo na yung A and B natin may kinalaman yan sa auxiliary rectangle natin. Okay? So, yung A and B pala may kinalaman yan sa dimensions ng ating auxiliary rectangle. And take note, a rectangle could be horizontal, meaning pahiga, vertical meaning patayo, or a square meaning the dimensions are equal. Okay, so that's why A could be greater than, less than, or equal to B. Now let's have the properties of hyperbola. So here you can see in the table the formulas in finding the properties of a hyperbola. So we have here the orientation equation, center, vertices, foci, and asymptotes. So we have for horizontal and for vertical hyperbola. Okay, so here, when the hyperbola is horizontal, the vertices are h plus minus a and k. So parang the same lang siya sa ellipse. Now, for the foci naman, we have h plus minus c and k. So, the same pa rin siya sa ellipse. And for the asymptotes, we have the equation y equal to plus minus b over a times the quantity x minus h plus k. Please take note that b over a here in the equation is just the slope of the asymptote. Okay? Now, for the vertical hyperbola naman, so the same pa rin yung center, yung vertices natin, nagkabaliktad lang. Okay? So, from h plus minus a, magiging k plus minus a na siya dito. Okay? For foci, nagkabaliktad lang rin. Okay? So, h plus minus c sa horizontal. For vertical, we have k plus minus c. Okay? For the asymptote naman, nagkabaliktad lang yung numerator at denominator ng slope nito. So, for vertical, we have a over b naman yung slope ng asymptote. Okay, so from this table of properties, we can have the following concepts. First, the center is the point midway the foci and the vertices. Makikita yan sa illustration. It is also the intersection of the asymptote. Okay, so yung point of intersection ng asymptotes natin ay yung center. Okay? For the vertices naman, as you can see in the formula, nagdi-differ lang siya sa center by that letter A. Therefore, the vertices are A units away from the center. So, meaning, center to one vertex, that is just A. So, the distance from center to one vertex is A. Now, the segment V1, V2 is the transverse axis and it has a length 2A. Bakit 2A? Center to one vertex is A. Since we have two vertices, so dalawang A yan. So we have 2A. Okay? Now for the foci naman, for the foci, as you can see in the formula, nagdi-differ lang siya sa center by that letter C. Right? So therefore, the foci are C units away from the center. Now, from the equation, standard equation, wala kang makikitang C. So how will you solve for C? So we have this property. C squared is equal to A squared plus B squared. So you just need the values of A and B to solve for C. Mamaya malalaman natin kung ano yung B. Okay? But the foci, again, are C units away from the center. So, meaning, center to one focus is just C. Okay? Now, for any point on the hyperbola, the absolute value of the difference of its distances from the foci is 2a. So, meaning yung tinutukoy sa definition natin na constant ay 2a lang pala, which is the same with the length of the transverse axis. So, kung ibibigay yung absolute value ng difference, that is just 2a. I hope that is clear. Next, for the asymptotes, those are the extended diagonals of the auxiliary rectangle. Kita naman sa illustration. And lastly, the auxiliary rectangle has two dimensions, 2a and 2b. So, saan galing yung 2a and 2b? Okay, with its diagonal intersecting at the center. So, for us to know that 2a and 2b, look at the illustration. The two sides of the auxiliary rectangle are congruent and parallel to the transverse axis. So, therefore, the two sides there has the length 2a. So, meaning this one is 2a and this one also is 2a. Kasi the same lang siya ng length ng transverse axis. Okay? The other two sides naman are congruent and parallel to the conjugate axis, meaning this side here is 2b and this one is 2b. Kasi yung length ng conjugate axis natin ay 2b lang. Therefore, center to one endpoint here of the conjugate axis is just B. So, yung B natin ay yung distance ng center to the endpoint of the conjugate axis. So, siya yung gagamitin natin to solve for C. Okay? So, those are the properties of the hyperbola. Now, if we are going to expand the standard equation of the hyperbola, we can get the general form of the equation of the hyperbola. And it is given by this one. We have ax squared plus by squared plus cx plus dy plus e equal to 0. Yung a, b, c, d, and e natin dyan ay mga real numbers lang. Okay? So here, a and b should not be equal and the product of a and b should be less than 0. Meaning, negative yung product ng a and b. So for us to have a negative product, a and b should have different signs. Right? So it could be that a is positive while b is negative, or a is negative while b is positive. Okay, so that is the general form of the equation of a hyperbola. Now, let's practice solving this one. Okay, so what we're going to do is to find the standard equation of the hyperbola that satisfies the given conditions below. So we have actually here three problems. So let's try problem number 1. Okay, so for problem number 1, we have the foci are f sub 1, negative 5, negative 3, and f sub 2, 9, negative 3. And the absolute value of the difference of the distances of any point from the foci is 10. Okay, now take note that the standard equation of the hyperbola depends on its orientation. Therefore, what we are going to do first is to identify the orientation of this hyperbola. One way is by plotting the given points on the Cartesian plane. From that, we can actually see the alignment of the given points. So suppose this is our xy plane. F sub 1, which is negative 5, negative 3, is actually somewhere here. And f sub 2, 9, negative 3 is somewhere here. Therefore, we can actually now identify the orientation since the given points are horizontally aligned. The orientation of this hyperbola is horizontal. Okay? And since it is horizontal, the form of the equation will be x minus h quantity square over a square minus y minus k quantity square over b squared equal to 1. And from that, we need the values of h, k, a, and b. Okay, now take note hk is just the center of the hyperbola. And since we are given with the foci, the center is just the midpoint of the foci. Therefore, using midpoint formula, we can actually solve for the center. So therefore, the center now will be, okay, using midpoint formula, letting f sub 1 be x sub 1, y sub 1, and f sub 2 be x sub 2, y sub 2, we will now have the center be equal to midpoint formula, x sub 1 plus x sub 2. So we have negative 5 plus 9 all over 2, comma, y sub 1 plus y sub 2. So that is negative 3 plus negative 3 all over 2. Okay, and that will be equal to 2 over 2 and negative 3. So there, we already have our center, 2, negative 3. So next is to solve for the values of a and b. From the given condition, the absolute value of the difference of the distances of any point from the foci is 10. And take note from our property, the absolute value of the difference of the distances of any point from the foci is just equal to 2a, right? Therefore, we can actually have 2a equal to 10. And from that, a is equal to 5, right? Next, for b, we know that from the Pythagorean identity, c squared is equal to a squared plus b squared, right? So therefore, it will follow that b squared is just c squared minus a squared. So therefore, for us to solve for b, we need the values of c and a. We already have our a, so we need the value of c. So we need to find c here. Take note, c is just the distance from the center to one focus. And since we are given with the foci, so taking one focus there, we can actually solve for C. Suppose I will just take f sub 2. Okay? So taking f sub 2, so actually, by the way, center is 2, negative 3, so it is located here. So this is our center, 2, negative 3. As you can see, the center and one focus f sub 2 are horizontally aligned. So therefore, we can actually solve for C by getting the absolute value of the difference of the x coordinates of these 2 points. So we have 2 and 9. So just take the difference, 2 minus 9 is just equal to absolute value of negative 7, which is 7. So we now have the value of C. Therefore, we can now solve for b squared. So b squared is equal to c squared minus a squared. C squared will be 7 squared minus a squared is 5 squared. So that is 49 minus 25. And that is equal to 24. So the value of b squared now is equal to 24. And from that, we can now have the standard equation of this hyperbola. So from our model equation, x minus h is 2, so we have x minus 2 quantity square over a squared, which is 5 squared, 25, minus y minus k. K is negative 3, so this will become plus 3 quantity square over b squared is 24 equal to 1. This will be our final answer. For problem number 2, we have here the vertices are 8, negative 2, and 8, 8, and a focus at 8, 12. The same with problem number 1, we need to identify first the orientation of this hyperbola. So suppose this is our xy plane. Since the vertices are 8, -2, which is located here, and 8, 8, which is here, okay, and the focus is at 8, 12, you can see there that the points are vertically aligned. Therefore, the orientation of this hyperbola is vertical. Okay? And since it is vertical, the equation of the hyperbola will be of the form y minus k quantity square over a square minus x minus h quantity square over b square equal to 1. So, okay, so we need to solve for the center first. Since we are given with the vertices, and take note that the center is the midpoint of the vertices, we can actually solve for the center using midpoint formula. And that is equal to, suppose v sub 1 is x sub 1, y sub 1, and v sub 2 be x sub 2, y sub 2, we have now the center equal to x sub 1 plus x sub 2, that is 8 plus 8 all over 2, and y sub 1 plus y sub 2, so that is -2 plus 8 all over 2, and this is equal to 8 and 3. So we already have the center, 8, 3, which is located here. So we have 8 and 3. Next, to solve for A, since we have the vertices, the distance from the center to one vertex is A, so we can actually solve for A here. Now, suppose I will just take V sub 2. Since V sub 2 and the center are vertically aligned, I can solve for A by taking the absolute value of the difference ng y coordinates. So from that, we have 8 minus 3, which is equal to 5. So we have A equal to 5. Now for B squared naman, um, using the Pythagorean identity, b squared equal to c squared minus a squared, we need to solve first for c. And c is the distance from the center to one focus. And we are given with one focus here, which is 812. So we can solve for the value of c. And that is equal to the absolute value of, since the center and the focus here are vertically aligned, we will take the absolute value of the difference of the y coordinates, which are 12 and 3. So we have 12 minus 3 is equal to 9. So we now have the value of c, so we can solve for b squared. So b squared will be c squared minus a squared, and that is equal to c squared is 9 squared minus a squared is 5 squared. So this will be 81 minus 25, and that will be equal to 56. So therefore, our final answer now, based on our model equation, will be y minus k is 3 quantity square over a square, that will be 5 square, which is 25, minus x minus h is 8 quantity square over b squared, which is 56, equal to 1. This will be our final answer. For problem number 3, we are given with the asymptotes y equal to 4/3 x plus 1/3 and y equal to -4/3x plus 41/3 and a vertex -1, 7. So the same pa rin yung gagawin natin. First, we will plot the given point here and the lines. So suppose this is our xy plane. From our given conditions, the asymptotes, take note that the form of the asymptotes is of the form y equal to mx plus b, right? So where your m here is the slope, this is the slope of the line, and b here is the y-intercept. Okay? So from that, we can have here our first equation, 4/3 plus 1/3, 4/3 is the slope, and 1/3 is the y-intercept. And for the second equation, negative 4/3 is our slope, and 41/3 is the y-intercept. So from that, we will first sketch the graph of the first equation. So the y-intercept of the first equation is 1/3. So 1/3 is somewhere here. And since the slope is 4/3, take note slope is rise over run. Therefore, we will move upward 4 units and 3 units down to the right because the slope is 4/3. So you count 4 units upward, so that will be um, 1/3. So 2 and 1/3 will be 2 units already. And 4 and 1/3 is 4 units. So it is somewhere here. And 3 units to the right. So this will be your other point on the line. So connecting the 2 points, we will now have the graph of the given line. For the second asymptote, the y-intercept is 41/3. That is 13 and 2/3. So it is somewhere here. Okay? So since the slope is negative 4/3, so we will move 4 units downwards and 3 units to the right. So that will be 14 here, right? 13 and 2/3. So minus 4, that will be 9 and 2/3. So it is somewhere here, right? And 3 units to the right. So the other point is there. And connecting the 2 points, we have that line. Okay? And the vertex is negative 1, 7. So there. So this is now the graph of this two lines and the point. So from that, since the point is located sa left side ng asymptotes, therefore we can say that the orientation of this hyperbola is horizontal. Okay, so this is a horizontal hyperbola. And the form of the equation will be x minus h quantity square over a square minus y minus k quantity square over b square equal to 1. Now, from our asymptotes, take note that the intersection of the asymptotes is the center. So this is now our center. But we don't know yet the coordinates of that center. So to solve for the center, since it is the intersection, we will just solve the system of these two equations. So what we are going to do here is by substitution. Okay? So I will substitute the first equation to the second equation. So this is your first equation. This is your second equation. So from the second equation, we have y equal to negative 4/3x plus 41/3. Okay? Take note from our first equation, y is equal to 4/3x plus 1/3. So I can just substitute this value to the y here in our second equation. So I will now have 4/3x plus 1/3 equal to 4/3x plus 41/3. Okay, so from that, I can now solve for x. Okay, solving for x, I will eliminate first the denominator. So I will multiply both sides by 3. So I will now have 4x plus 1 equal to negative 4x plus 41. Now, combining like terms, so I will now have 4x plus 4x. So from negative x, so I transferred it to the left-hand side of the equation. So magiging positive 4x siya. And equal to 41. 1 from the left side, going to the right side, it will be negative 1. Okay, so we will now have 8x equal to 40. So x is equal to 5. Okay, so we now have the value of x. To solve for y, you just substitute x to either of the two equation. So it could be equation 1 or equation 2. So here, I will just use equation 1. So I have y equal to 4 thirds x plus 1 third. When x is equal to 5, so we have y equal to 4 thirds times 5 plus 1 third, right? So here, x is equal to 5. Okay? So we now have y equal to 20 over 3 plus 1 third. So y is equal to 21 over 3, and that is 7. So the coordinates of the center now is 5 and 7. Okay, so we now have the values of h and k. What's left is the value of a and b. For a, since we have the vertex and the center, we can solve for a. Since they are horizontally aligned, a now will be equal to the absolute value of the difference of the x coordinates, which are negative 1 and 5. So we have negative 1 minus 5, that is equal to 6. Absolute value of negative 6 is 6, right? Now, to solve for b, take note that the slope of the asymptote for horizontal hyperbola is just b over a, right? And since the slope here is 4 thirds, so I can have b over a equal to 4 thirds, right? So since we have a which is 6, substituting, we have b over 6 equal to 4 thirds. We can now solve for b. I will just eliminate 6 here, so I will have b is equal to, this is 2, so 2 times 4 is 8. So we now have the value of b, which is equal to 8. Thus, the final answer will be x minus h is 5, quantity square, over a squared is 6 squared, which is 36, minus y minus k is 7, quantity square, over b squared is 8 squared, which is 64, equal to 1. This is now our final answer. Now let us try answering another type of problems involving hyperbola, that is identifying the center, foci, vertices, and asymptotes of the hyperbola with the given equations in each item. Okay, so we will also sketch the graph of these hyperbolas indicating these points and line. Okay, so we have here three equations. So let's have equation 1 first. Okay, so we have x squared over 16 minus y squared over 20 equal to 1. Now, take note, if the equation is written in standard form, we can easily identify the properties of the given hyperbola. So here, since this equation is already written in standard form, so there's no more problem. Okay? So what we're going to do is to identify the values of h, k, a, b, and c. Okay? So here, first, we have the orientation. Since the positive part here is x, the orientation of this hyperbola is horizontal. Okay? So we have a horizontal hyperbola here. Now, for the center is just HK, and our HK here are 0 and 0. So the center is at the origin. So from the standard equation, we can actually solve for A and B as well as for C. So A squared from our standard equation is just equal to 16. So A is equal to 4. Okay? While b squared is equal to 20, therefore b is equal to square root of 20. Okay? And for c, that is just equal to the square root of a squared plus b squared from our Pythagorean identity. And that will be equal to the square root of a squared is 16 plus b squared is 20. So that is square root of 36, which is 6. So A is equal to 4, B is square root of 20, and C is equal to 6. Next, the vertices are A units from the center, and since it is the hyperbola here is horizontal, so the vertices are located 4 units to the right and to the left of the center. Okay, so our formula will be h plus minus a k, right? So from that, v1 will be, we will take first the subtraction. So we have h minus a k, and that will be 0 minus 4, 0, and that is negative 4, 0. Okay? For v sub 2, we have h plus ak. Okay? So that will be 0 plus 4, 0. So v sub 2 will be 4, 0. So we have now the vertices. Next, for the foci, that is C units away from the center, so we have H plus minus C and K. So F sub 1 will be H minus C K. So that will be 0 minus 6, 0. So that is negative 6, 0. F sub 1. For F sub 2, that is H plus CK. So we have 0 plus 6, 0. So that is 6, 0. So we have now the coordinates of the foci. Next, for the asymptotes, since it is horizontal, the formula will be y equal to plus minus b over a x minus h plus k. So from that, we have y equal to plus minus b is square root of 20 over 4, okay, times the quantity x minus h is 0 plus k is 0. So from that, we have simplifying square root of 20. Square root of 20 is 2 square root of 5. So 2 square root of 5 over 4, that is square root of 5 over 2 x na lang. Okay, so this is now the asymptotes. Okay, from this, we can now have the graph of the hyperbola, which looks like this one. For equation number 2, we have the quantity x minus 1 squared minus y squared equal to 4. So we need to transform this equation first into its standard equation. And take note, the standard equation of the hyperbola, the right side should be equal to 1. Okay? Since the left side of this equation are already perfect squares, so we will just have the right side be equal to 1. So from that, I will just divide um, every term here by 4 to make the right hand side of the equation equal to 1. So dividing this by 4, divide this by 4 and this one by 4, we will now have x minus 1 quantity square over 4 minus y square over 4 equal to 1. This is now in standard equation. And from this, since the positive part is yung x, we can now have the orientation horizontal. Okay? And the center HK is, so our H is this one, and that is 1. Since minus 1 yan, magiging positive 1 dito. And your K is 0. So the center has the coordinates 1, 0. And from our standard equation, a squared is just equal to 4. So a is equal to, this is 2, right? B squared is also 4. So b is equal to 2. And c is square root of a squared plus b squared, which is equal to 4, no, square root of 4 plus 4, and that is equal to square root of 8. Okay? or this is 2 square root of 2. So from that, we can now have the vertices. Since the orientation is horizontal, so the formula for the vertices will be h plus minus ak. So v1 will be h minus ak, and that will be 1 minus 2, 0. So we have negative 1, 0. For v2, we have h plus ak. So that will be 1 plus 2, 0. So we have 3, 0. So we now have the vertices. For the foci, we have h plus minus ck. So f sub 1 will be h minus ck. So that is 1 minus 2 square root of 2, 0. So that's it. Now, for our f sub 2, we have h plus ck. So this will be 1 plus 2 square root of 2, 0. So we now have the foci. Now, for the asymptotes, since this is horizontal, we have y equal to plus minus b over a times x minus h plus k. So that will be y equal to plus minus 2 over 2. Then xh is 1 minus 1 plus 0. So this will become y plus minus 2 over 2 is just 1. So that will be plus minus x minus 1 na lang. So we now have these properties. And from these properties, the graph of the hyperbola will look like this one using Desmos. Okay, so that is now the graph of the second equation. For equation number 3, we have 25x squared minus 39y squared plus 150x plus 390y plus 225 equal to 0. We need to transform this equation into its standard form. So what we are going to do is to complete the squares here and transform it to its standard equation. So what we're going to do is to group all x's and y first and isolate the constant term so that we can complete the squares later. Okay, so first group will be the terms with x. So we have 25x squared plus 150x. So this is our first group plus the terms with y. So that is negative 39y squared plus 390y equal to negative 225. Now, observe that the leading coefficients are not equal to 1. So we need to factor out those coefficients so that we can complete the squares later. So we will factor out 25. So factor out 25. What's left now is x squared. 150x divided by 25 is 6x. Okay? Then factor out negative 39. So what's left is y squared. 390y divided by negative 39, that will be negative 10y equal to negative 225. Okay? So from that, we can now complete the squares. So we will add something here sa first group plus there minus 39 times y squared minus 10y, and we will also add something here equal to 225 plus we will add two values here. Okay, next we will now complete the square. So taking 6 here, 6 divided by 2 is 3. Squaring it, you have 9. So we will add 9 sa first group. And for the right-hand side, we will add 25 times 9 since we have a multiplier 25 here. Okay? Next, for the second one, we will take negative 10 divided by 2. So that is negative 5. Squaring it, you have 25. So we will add negative 39 times 25 here since we have a multiplier negative 39 here. So from that, we can now have the factored form of this equation which is 25 times x plus 3 quantity square, right? Minus 39 times y minus 5 quantity square equal to, if we will add all terms here, this will be equal to negative 975. Okay? Next is to make the right-hand side of the equation equal to 1. So we will divide both sides by negative 975. So divide it by negative 975, also this one. So what will happen is, since 25 over 975, we can still reduce this one. The common factor is 25, so this will become 1. And this is 39. So we have negative of x plus 3 quantity square over 39. Okay, for the second term, that is 39 over 975. This can be reduced. Okay, the common factor is 39. So this will become 1. Yung numerator, the denominator will become 25. And negative over negative, that will become positive. So you have plus y minus 5 quantity square over 25 equal to 1. This is not yet in standard form since the first term is negative and the second term is positive. So what we are going to do is to rearrange this one. So we will must have a positive term first. So this will be y minus 5 quantity square over 25 minus x plus 3 quantity square over 39 equal to 1. This is now in standard form. And from that, since the positive term is y, the orientation of this hyperbola is vertical. Okay, so we have a vertical hyperbola. Next, for the center HK, our h is the partner of x. So this is our h. So that will be negative 3. And our k is, you have here 5. So HK is negative 3, 5. And from our standard equation, we can solve for A, B, and C. So A squared is just equal to 25. A will be equal to 5. B squared is equal to 39. B will be equal to square root of 39. And C is equal to square root of A squared plus B squared. And that will be square root of 25 plus 39, which is square root of 64, which is equal to 8. So we have the values of A, B, and C here. So we can now solve for the other properties. First, the vertices. The vertices, since it is vertical, the formula will be HK plus minus A. So V1 will be HK minus A, right? So that will be negative 3, 5 minus A is 5. So this will be negative 3 and 0. For V2, that is HK plus A. So that will be negative 3, 5 plus 5. So that will be negative 3 and 10. Okay, so we have now the vertices. Now for the foci, we have the formula HK plus minus C. So F1 will be HK minus C, and that will be negative 3, 5 minus C is 8. So you have negative 3, negative 3. For F2, we have HK plus C. So this will be negative 3, 5 plus 8. So that will be negative 3 and 13. So we now have the foci. And for the last property, the asymptote, since it is vertical, we have the formula y equal to plus minus a over b x minus h plus k. So y now is equal to plus minus a is 5 over square root of 39, our v, times the quantity x minus h. H is negative 3, so this will become x plus 3, right? Plus k is 5, so we have plus 5. So these are the properties of this hyperbola. And from that, we can now have the graph of this hyperbola, which looks like this one using Desmos. Okay, so that's it for the third equation. For the last practice problem, we will try to solve some situational problems involving hyperbola. So we have here two problems to consider. Number one is an explosion problem, and number two is a navigation problem. So let's have problem number one. Okay, so we have here an explosion was heard by two stations 1,200 meters apart, located at f sub 1 negative 600 0 and f sub 2 600 0. Therefore, our station 1 is f sub 1 and station 2 is f sub 2. Now, for us to better understand this problem, let's try to plot the points on the Cartesian plane. Okay? Suppose this is our xy plane. F sub 1 is negative 600 0 and f sub 2 is 600 0. Now, going back to the problem, if the explosion was heard in f sub 1 2 seconds before it was heard in f sub 2, identify the possible locations of the problem. So we are given here with the time difference, which is equal to 2 seconds. So it is the explosion was first heard in station 1, which is f sub 1. And the time difference is 2 seconds. Okay, so the problem is to identify the possible locations of the explosion. We will use 340 meters per second as the speed of the sound. So we are given with the speed. Okay, that is 340 meters per second. Now, from our previous knowledge in physics, the speed, okay, let's denote the speed as v. The speed is just equal to the change in distance or the difference in the distances. So let's denote that one as delta d over the change in time. So let's denote that one as delta t or the time difference. So from that, the change in distances is actually equal to, or that is delta d is equal to the speed times the time difference. Okay? Since we are given with the speed and the time difference, we can actually solve for this difference in the distances. Okay? And that is equal to 340 meter per second times 2 seconds. And that is equal to 680 meters. Thus, the difference of the distances of the explosion from the two stations is 680 meters. Now, let's compare this statement from the concept that we know about hyperbola. Okay, we have this one. The difference of the distances of any point on the hyperbola from the two foci is constant. Okay, this is actually from the definition. Therefore, we can conclude that the explosion is any point on the hyperbola lang, where the two stations are the two foci of the hyperbola, and 680 meters is actually the constant. Okay, thus, the possible location of the explosion is anywhere along the left branch of the hyperbola. Okay, why is it left branch? Because the explosion was first heard in station 1, which is F sub 1. Therefore, the explosion must be near F sub 1. Okay? So, the explosion is anywhere on the left branch of the hyperbola. Then it will follow that to solve the problem, we will just need to find the equation that will describe this hyperbola. Okay? So, yung hinahanap ng pala dito ay yung equation ng hyperbola. We will just restrict that one sa left branch. Okay? Now, since from the illustration, from our diagram, it is clear there that the center is at the origin. So our center is 0, 0. Then it will follow that the form of the equation to be used here is given by x squared over a squared minus y squared over b squared equal to 1. Since our hyperbola is horizontal. So we need the values of A and B na lang. Okay. Now, from the properties of hyperbola, the difference of the distances of any point on the hyperbola from the two foci is 2a, right? So therefore, we can deduce that 2a is just equal to 680 because that is the difference of the distances that we got, which is 680. And it will follow that a is equal to 340. Okay? So we now have the value of a. So what's left now is the value of b. Okay? From the Pythagorean identity, b squared is equal to c squared minus a squared. So we can only solve for b if we have the values of a and c. A is already given, which is 340. So we need to solve for c. Now, take note that f sub 1 and f sub 2 are the foci of the hyperbola, right? So therefore, center to one focus is actually the value of c. So from here, the center to one focus, suppose that is f sub 2, c is just actually equal to 600, right? So therefore, we now have the value of c. So we can now solve for b squared. So b squared is just equal to c squared minus a squared. And c squared is just 600 square minus a squared is 340 squared. And that will be equal to 360,000, right? Minus 340 square is just 115,600. Okay, taking the difference, that will be 244,400. Thus, b squared is equal to 244,400. Okay, so we can now give the final answer. Okay, so the final answer will be, just substitute the value of a and b to the equation. So that will be x squared over a squared is 340 squared, that is 115,600, okay, minus y squared over b squared is 244,400 equal to 1. Thus, the possible locations of the explosion is anywhere along the hyperbola described by this equation, x squared over 15,600 minus y squared over 244,400 equal to 1. Restricted on the left branch. Okay? So that is the answer for this problem. For problem number 2, we have here two LORAN or long-range navigation stations A and B are situated along a straight shore, where A is 200 miles west of B. These stations transmit radio signals at a speed 180 miles per millisecond. Now, the captain of a ship traveling on the open sea intends to enter a harbor that is located 40 miles east of Station A. Now, due to its location, the harbor experiences a time difference in receiving the signals from both stations. The captain navigates the ship into the harbor by following a path where the ship experiences the same time difference as the harbor. Now, problem letter A. What time difference between station signals should the captain be looking for in order the ship to make a successful entry into the harbor. Okay, so for us to answer this question, let us first sketch the diagram of this problem on the XY plane. Now, suppose this is our XY plane, and suppose the x-axis is the shoreline, where the upper part, okay, is the open sea, and the lower part is the shore. Okay, now since um, station A is 200 miles west of B, so therefore A is located sa left side ng B. Okay? And the distance is 200 miles. Suppose the midpoint of these 2 points is at the origin. So therefore, my point A is located here and my point B is located here. Okay? These two stations transmit radio signals at speed 186 miles per millisecond. So the speed of the radio signals is already given. That is 186 miles per milliseconds. Now, the harbor is located 40 miles east of Station A. So the harbor is on the right side of the station A. So that is here, right? 40 seconds. So that is by 20 kasi itong interval natin. So it is located at point -60, the harbor. Okay. Now, the problem is to determine the time difference. Okay? Between the two stations, right? Okay, when the two stations transmit radio signals. So we will determine that time difference. Now, this is just the same with problem number 1. In problem number 1, we are looking for the difference of the distances, right? So here, we are going to look for the time difference naman. Because if we have the same time difference, it will follow that we will have the same difference of the distances since the speed is constant, right? So if that's the case, we can actually use the same knowledge that we know about physics. Speed is equal to the difference of the distances over the time difference. And since we are looking for the time difference is just equal to the difference of the distances over the speed. So therefore, we need here the difference of the distances since we already have the speed. Now, take note, the same with problem number 1, the difference of the distances is actually the constant. Okay? The constant difference that we will get sa hyperbola. Thus, in that case, the ship is just following the curve of the hyperbola on the left branch. Okay? And what is the constant difference? That is just equal to 2a, right? So therefore, we need to know 2a here. And that 2a will be our delta D. Okay, so I hope you can follow. Again, 2a is now delta D. And take note, a is just the distance from the center to one vertex. And since we have here A and B as our foci, since sila yung ang kinukunan natin ng time difference, right? Sila yung kinukunan natin ng time difference. A and B now are our foci. If that's the case, since the harbor is on the hyperbola and it is aligned on the foci, the harbor now is one of the vertices. Okay? So here, A is one of the foci, B is one of the second focus, so we have F1, F2, and the harbor is one of the vertices now. So we have V1. So from here, the center now is at the origin. Okay, so we have 0, 0. So from that, center to harbor is just equal to your A, right? And that is equal to 60. Okay, so A is just equal to 60. And center to focus is just your C, right? And that is just equal to 100. So we have now the values of A and C. Okay? So from that A equal to 60, we can solve for 2A. And 2A now will be equal to 2 times 60, and that is equal to 120. And that will be our value for delta D. So by substitution now, we will now have 120 over the speed is 186. Okay? 120 over 186 is just equal to 0.65. The unit of measurement is milliseconds. So this is now the answer for letter A. So I hope you can follow. Okay? So let us now proceed to letter B. If the desired time difference is achieved, so we have now the time difference, which is 0.65 milliseconds. So we will still follow this path, or meaning this hyperbola. Okay? Determine now the location of the ship if it is 75 miles offshore. So from the shoreline going to the ship is 75 miles. Okay? So I will just erase this um, writings here sa problem letter A. So we will proceed to letter B. So we will still use the same information. So here, the ship is 75 miles offshore. So from the shoreline to the ship is 75. So the ship is located here. So it has the coordinates x 75. So our y is 75, which is this one. And our x, we don't know that one. So we will need to solve for x here. But before that, we must identify the standard equation to be used. Okay, since the center is at the origin, so we will now have the form of the standard equation, which is x squared over a squared minus y squared over b squared equal to 1, since the hyperbola is horizontal. Okay? We already have a equal to 60, so we need to solve for b squared. And since we already have c equal to 100, b squared now is equal to c squared minus a squared. And that will be 100 squared minus 60 squared. And this is equal to 10,000 minus 3,600, right? And this is 6,400. So therefore, the equation of the hyperbola will be x squared over a squared is 3,600 minus y squared over b squared, which is 6,400, equal to 1. So this will be now the equation that we are going to use to solve the problem. So to solve for x here, we just substitute the value of y, which is 75. So when y is equal to 75, we will now have x squared over 3,600 minus 75 square over 6,400 equal to 1. Okay? Now, 75 square over 6,400 is just equal to, copy muna natin tong first term. Okay? So, this is equal to 225 over 256. This is now in lowest term. Okay? Equal to 1. Okay? So from that, solving for x, lipat natin to sa kabila. Okay? So we will now have x squared over 3,600 equal to 1 plus 225 over 256. And this will become, okay, x squared over 3,600 equal to, this is just equal to 481 over 256. Okay, 1 plus 225 over 256 is 481 over 256. Now, solving for x squared, we will multiply both sides by 3,600. So this will become x squared equal to 481 over 256 times 3,600. Now, taking the square root of both sides, okay, taking the square root of both sides, x now will be equal to, so that is approximately equal to 80 plus minus 82.24. So we have two values of x's here. But since the point is located on the second quadrant of the xy plane, therefore we will just take the negative value. Thus, okay, the location of the ship is negative 82.2475. So this is now our final answer. Okay, so that ends our lesson for hyperbola. So I hope meron tayong natutunan ngayon. Thank you for watching.